Hi, everyone. Just wanted to take a little bit of time to talk about transformations and then to specifically focus on reflections. So these are the notes that we're going to be going over in class. This way, you can, if you have to miss it or need to review or go over something again, you can still look at this information. All right. So as I said, we are moving on to transformations. You may know these as being reflections, rotations, and translations. You also might be familiar with dilations. However, for right now, we are not going to focus on those. We are only going to specifically focus on these three because these three, as we'll talk about later, preserve a lot of properties. All right. So, our objectives. So we are specifically going to be looking at describing and identifying different types of congruence transformations, and then reflect points and objects over the x-axis, y-axis, and the line y equals x. So we're really kind of focusing on those three particular lines. You can do reflections over anything, but those are the three we're going to focus on. All right. So some of our key vocab. A transformation, that's just changing a shape using a turn, flip, slide, or resize. So those are the reflection, rotation, translation, and dilation that we had just spoken about. But ultimately, all we're doing is we're taking a shape and we're either moving it around, flipping it over, um, turning it slightly, or in this case, we're going to stop there. We're not going to do the resizing, but you can do that as well. And then an isometry is a transformation that preserves length, shape, and the shapes are congruent. All right. So those are the ones we're specifically caring about. And the three that we had listed before, the three isometries, are going to be your reflection, your rotation, and your translation. Okay. Um, so ultimately, what we're doing with these is we are looking at the fact that they retain distance and length. So that is very important for us because that means the shapes will stay congruent. They might not be in the same orientation in terms of now we have A pointing up as opposed to before where it was off to the side, but they are congruent shapes. All right. The other thing you might see is as opposed to being called an isometry, you might see it called a rigid. Um, a rigid transformation. You could also call it a congruence transformation. Any of those are acceptable alternatives to isometry. And just a little fact, metry means measure and iso means same. So it just means same measure. All right. So let's specifically talk about the three that we are focusing on. So let's start with the reflection. So the reflections, those are the flipping, right? So that is where you flip a image over a line of reflection. In this case, the line of reflection shown is the line y equals x, but we need to have some sort of um, line as a reference point. The ones we're going to be focusing on are the x-axis, the y-axis, and the line y equals x. This is the line y equals x, the diagonal one going right through them. A few pieces of information. So the original image, as you can see here, the original image is the pre-image. So this right here, this is our pre-image. All right. And then the image after you've transformed it. So this is true of all transformations, not just reflections. The image after you transformed it is just called the image, right? The object here. So this would be the image. Now, you're probably wondering how I identified that, given the fact that I wasn't explicitly told. But you'll notice the image, the afterwards, is labeled with things like the primes here. So see how it's A prime, B prime, C prime? That's what that little dash means. So that means prime. And that's how you can indicate that this is the image. This is the afterword. All right. So again, we're going to specifically be focusing on reflections, the flipping over the x-axis, so right here, the y-axis, and this line, y equals x. And there's very nice rules for these. All right, so rotations. So the rotation, that's the turn. You have to have a fixed point as your center of rotation. The most commonly used center of rotation is the origin. You could technically use anything, but that is the most common. Again, it retains shape and size, but Now the kind of like the ordering, right, might look a little different. See over here, this point was facing to the right. Now it's facing up. Now it's facing to the left. Now it's facing down. So that's kind of some of the things that are different. Um, Going forward, we're going to be looking at how rotations can be clockwise or counterclockwise. Um, and you're usually doing it in terms of an amount of degrees. So 90, 180, 270. Those are the common ones. All right. And we'll talk more about rotations and translations more later, but let's just finish this overview. The translations, this is your slide. All objects are moved in a straight line in the same direction. So, right, all the points. So, A, it's going this far. B, it's going this far. C, it's going this far. They're all going the same distance. So, this is your slide. It's moving over. It's the only difference. Again, size and shape and orientation on this one are retained. It's just in a different location. And again, the orientation is the same, meaning the pre-image and the image are facing in the same direction. So before on the rotation where A, kind of went around in a circle, now A is still in the same line as A. So some combinations you could be looking at just horizontal, so just left and right, vertical, up and down, and then vertical and horizontal, which is a combination that creates an ultimate diagonal effect. All right, so let's look at this reflection. So that's really what we're focusing on today. And as I said, we're going to focus over 3 different lines of reflection: the x-axis, the y-axis, and the line y equals x. So whenever you are dealing with a reflection across the x-axis, as you can see here, I'm starting here, and I can tell that this is my pre-image because it does not have prime. So again, here's my pre-image. All right, and here's my image. Again, be careful with your primes. So as you can tell, we're going from here down to here, here down to here, here to here. You'll notice that when I'm drawing these arrows, they're all different lengths. The distance that they're shifting is different from point to point. It's just that we're reflecting, right? If you kind of like folded your paper in half, that's what you're looking at. However, you'll also notice that when we're looking at these points, the x's are the same. The x's are the same. The x's are the same. And the y's are very close to each other. The only difference is that the y here, if it's 1, now it's -1. 4, now it's -4. 2, now it's -2. So all you're going to do anytime you're reflecting over the x-axis is you just take the point xy and you make it x -y. All right? So if you reflect across the x-axis, you just change the sign of y. And the same thing goes. So if I had a point down here as part of my pre-image and then it went up, you would just change it. Okay, so let's look at an example of that. So if we were to try this, if we were to reflect this over the x-axis, now you could graph this if you wanted, but for our purposes, we're just figuring out the coordinates. So again, all I'm doing, because I'm reflecting this over the x-axis, is I'm taking my points x, y, and I'm rewriting them as x, -y. All right, so m, -1, and I change the sign of y, so it's -5. D, 1, again, negative, negative, -5. 4, -3. I'm changing the sign. All I'm doing is I'm going in and I'm changing the sign of my y coordinate. And again, if it was negative, it would become positive. So let's say, for example, I had 2, -3. If I were to reflect that, my point would be 2, 3, right? See, I'm just changing the sign. Okay, so that should be straightforward enough. Ultimately, once again, as a reminder, all you do is you change the sign of y. All right. Now let's look at our reflection over the y-axis. So again, we have our y-axis. Here we have our pre-image. And here's just my image. And I can tell once again because it's A, B, C, not, and then this one is A prime, B prime, C prime. So all we're doing, now we're reflecting over this line, right? Okay. So now we see we have 4, -4, 5, -5, 1, negative 1. However, now the y coordinates are the same. So now it's 3, 3, 2, 2, negative 1, negative 1. So now the only thing that differs is that my x coordinates change sign. So what we're going to do is you're just going to take the x coordinate, and you just change the sign. So same thing as the rule before, except now we're dealing with x. So you just change the sign of x. So 1 goes to negative 1, 5 goes to negative 5, 4 goes to negative 4. Similarly, if you had negative 4, and it would go to 4. All right, so let's do that example. So if I were to reflect this over the y-axis, again, because I'm flipping this over the y-axis, my point xy, when I flip it or reflect it, I change it to negative x, y. All right, so I get 0. Obviously, you flip 0, you don't do anything, right? 2. Okay, so that doesn't change at all. It's on the line, so it will not change. And how would we know that? Because it's actually on the y-axis. So whenever you get a point on the actual line of reflection, it doesn't change. All right. So negative 2, 3. So again, we're just changing the x value to 2, 3. All I did was I took the negative 2, changed the sign, so it's positive. Q prime, I'm going to change the sign of negative 1 to 1, leave the y alone. P, I'm going to change the sign of negative 3 to just 3, negative 2. Right? And that's all there is to it. So again, you just change the sign of the x value, you do not touch the y value. One last one over the line y equals x. So now, again, we have our image and our pre-image. Ooh, here's my pre-image, sorry. Here's my image. So let's look. We start at negative 3, 1. And my point is 1, negative 3. Negative 1, 4, 4, negative 1. Negative 1, 0, 0, negative 1. So what's happening? All that's happening is that x and y are switching. And that just comes from the fact that this is like dividing it in half, right? So this would be if you folded your paper diagonally. So you just are switching your x and your y coordinates. So negative 1, 4 goes to 4, negative 1. Negative 3, 1 goes to 1, negative 3, and so on and so forth, right? So if we were to reflect this across y equals x, I'm just going to flip x and y. So my new coordinate would become yx, all right? So w prime would be 3, negative 2. I'm just flipping these, right? Same thing goes here. 1, negative 2. Negative 2, negative 4. Negative 1, negative 5. That's it. I just flip, all right? Simple enough. And finally, let's say you were given something and you were just told that a reflection occurred. Basically, all you're going to do in that instance is you're going to look and say, does it follow any of these rules? And if it follows any of those rules, it would be a reflection over the x-axis, a reflection over the y-axis, or a reflection over the line y equals x, all right? So those are just some things to consider. So if you ever see that x and y are switching, you would know it's y equals x. That's what you're flipping over. If you see that x has changed signs or that y has changed signs, you know it'd be over one of the axes. All right, so let me know if you have any questions and have a great day.